to learn Overflow. In this video, I was thinking of creating something like a cartoon. Okay, so not a normal one, but let's try to create some image cartoons, maybe some of our favorite personals whom we like. So we'll try to create a cartoon of them. How about that? So I will use again Python to create this cartoonized image, and let's start with this. So first of all, we would need to create a new file where we can work on our cartoon. Say we say cartoon, and that's a Python file we're creating. So just a second, it's the cartoon.py is the file that got created. All right. So now the first thing we want to do is take our image and then cartoonize that. We want to make the image a bit cartoonized. Okay, so that's our target now. First of all, so whenever it comes out image, if you have seen my past videos, so I prefer OpenCV to be the best one for all these purposes. So let's start with importing libraries, and we will import firstly the OpenCV. That's import CV2. That's the main library we need here. So if you need any other libraries on the go, I will import that whenever required. Okay, so first of all, import CV2. All right, we got our CV2 library. Okay, now first thing we need an image. We need an image to work on. So we'll say image would be CV2 dot. We need to input the image. So whenever we are trying to input the image, then I am show is the best one for this. Okay, so I'm showing the best one for this, and next thing we need is a we need to take some image as input here. Okay, let's find an image and add this. So let's see what images we have here. So here I will use a PNG image, and here I got a PNG image, and this image is of Mr. Satya Nadella. And yeah, let's use this image and try to cartoonize this. Sorry, I don't mean to harm anyone, but this is just a educational point of view. Let's try to look at this. So first image we will try to enter is a.png. Okay, so we got our images. So the first thing we got is we took an image as an input. Okay, now let's try to convert this image. Let's try to first convert this image in some means, and then we will cartoonize this part. After that, the work comes to show our images. Okay, so first let's try some edges on this and try to work on this image and find some edges. Okay, so first thing we will try to do, so we'll first try to form a gray image out of this, and that's the basic step that we do whenever we start working with OpenCV and try to work on images. So let's take a gray image. So we'll take a gray image and we'll say a variable gray, and we'll say cv2 dot cvt cvt color. Yeah, cv2 dot cvt color. And this, look, whenever you are using cv2 dot cvt color, and it takes a source image, it takes you can either give the destination, you can either give some other kind of code to work on it. This is the way cv2.cvt color works. So that's basically we are trying to convert its color. Okay, so the code is basically what change you are trying to do. So we'll say cv2.cvt color, and then we will just pass our image in it, and with that image we need to pass on some code. And so code will be cv2 dot we want to convert this bgp to say gray. So we are trying to convert it to gray, so we need to do something like color bgb to gray. So that's the code we have. So yeah, that's the code we gave, and then whenever we are converted this color, like we got a gray image, why not let's try to show this image and see what we get. Okay, so we'll just try to understand each step, and we'll try to just print on each step to see if what we are getting out of each step. cv2 dot oops yeah cv2 dot we will say I am show. Oops, I think I did a small mistake here. This is not I am show. We are trying to read the image, so I am read will be the best one. It will be the perfect one. And here, when we're trying to output the image, then we need I am show. So we got a I am show. So we do I am show, and now we're trying to let's say show the image what we got. Okay. So first thing we want to show is say the age. We say gray, and we'll suggest our name we got, and then we'll just uh, print a gray. All right, let's run this a bit and see what actually this is giving us. Okay, let's understand it step by step. So like we'll just here we can actually figure out whether we have any mistakes in it or not. So if it runs properly, okay, so what happened here, we just printed this, but we didn't ask it to wait. So we'll say cv2 dot wait key, yeah, wait key, and we'll just say 0. So if we do that, in that case, this would the output would work. So what just happened? To understand what just happened, we need to do print out another thing. Okay, so we would say here we are trying to printing out so our image or the original image. The first, let's print our original image and the gray image what we got created. So we can just compare the both. Basically, we had a colored image, so we first converted into a grayscale image. Okay, so we just converted our image to a gray one. Now we need to do a median blur on this. Okay, we need to make a slight median blur on this particular image to just figure out what's happening with the image. Okay, so let's close it one by one, and then let's work on our image further. Now we got a gray. Okay, then reuse of variable, say gray, and then gray is basically we'd say cv2 dot median median blur. Yeah, cv2 dot median blur, and we need what? We need first src. So we need a source. So source would be our gray. Gray means the previous image we got just now, and then we would say how much we are willing to blur, like the median blur. Say we can work with first say 10, and that's the case size. And wait, let's make this gray one, and this would be gray one. We would print gray one here, and then we print gray here. So let's understand what's basically. So we basically don't need the original image now, but yeah, for comparison we can see all these images and side by side and just try to understand. It's okay. It says okay. Sorry. So gray one, this cannot be 10. So let's case size mod 2 double equals 0. Here it gives an error. So cv2 gives you an error. That's Opencv error. And what it says this kind of formulas. So whenever we are giving, we need to give a okay, mod 2 double equals 1, this becomes false. Okay, so let's say we give 9 here. Let's try this, and we'll just modify it whenever it's required. Okay, look, so this was the original image, this was the gray image, and where's the other one? Gray one. What did I print? Wait, this should be gray one. Now let's run this and try to understand what we got created here. Okay, so this is gray one here, gray here. Look, what we tried to do, this is the original image we had. This is a gray image, so we got the black and white image. And next thing we try to do is a bit blurred the image. But look carefully, this image actually got blurred to a max, like a more blurred, like we cannot figure out who the person is by this kind of blur, right? It's tough to figure out exactly who the person is. So why not just reduce the blur and try out experiment with it and try to figure it out. So let's say we give it 5, and we just reduce the like the k size of the blurring. Now look, from this gray one to gray, you can actually identify that, okay, this is the person. Look, you can with this kind of slight blurring, you can actually figure out who the person is. Okay, at least you can give a rough estimation. So that's how a cartoonization occurs. Like you're just trying to convert it to some extreme so that a bit blurred so that you can work on it. So you can reduce, if you want, you can reduce it to even 3. But remember, you you odd numbers, otherwise you will get an error. So yeah, look, if I give 3, then this is more or less almost the same one. So I guess giving a 5 blurring to a scale of 5 is quite good. Let's now walk further. So we got a bit blurred image. Okay, so after that, next thing we need to do, we need to find the we need to do an adaptive threshold. So let's try to understand how this works. So we'll say age, variable say ages, and then within this ages we'll try to do cv2 dot, cv2 dot, we'll say adaptive threshold. cv2 the adaptive threshold is here, and this should work on gray. Okay, so this would work on gray, and after that we need to give it some value. So this can be I guess 0 to no, this is the maximum value. So whenever you are asked to give a maximum value, go for 255 because it ranges from 0 to 255, and there's a value, maximum value can be 255. Remember, 256 cannot be, because yeah, it starts from 0 and ends still 255. Now you give its maximum value. After that, it wants adaptive method. So what by what method you want this adaptation, like adaptive method, you need to specify. So we'll use here cv2 dot adaptive. Wait a minute, I just made a mistake, and that mistake is missing a comma. Yeah, cv2 dot, we need adaptive threshold mean. Adaptive threshold means C, and that's a method that we want to use here. After that, we need it says whatever threshold type you want. So by this threshold type, you will use cv2 dot. There comes threshold thresh binary. Yeah, thresh binary is the threshold type we want to use here. After that, it says block size and C. So block size, with block size you can go with 9, and say C you go with 9. Okay, leave it. I will just explain later how what this happens here. So you got your age here. Now let's print this as well. Let's print this as well. So we got our age, and with that edg is ages. We got our ages. Now let's print this and understand what are we trying to do out of this. Look what we actually tried to do. This was the original image. This is the gray image that we did. This is the blur effect that we made on our grayscale image. Now after the blur scale, what we tried to do, we just tried to mark its outlines. We just tried to mark the outlines so that we can actually make it look like an image, like look like a cartoon, right? We just trying to cartoonize the image a bit. Okay, we're trying to work on this image and trying to make it a bit like cartoon. Look, in the original image you can get sharp edges, like the pixel quality should be sharp, but look here, what we got in our fourth outcome is a bit lighter, like it's a bit demolished one. Okay, there isn't any particular sharp boundaries, but yeah, you are just getting those areas highlighted where shadows are there. Okay, now let's close it and now start working further. So here we just got our ages. After we have got our ages, it's time to create our cartoon. Now here the ages are here, like the ages of the picture are clear to us. Okay, now we need to add color to it, but we don't want our cartoon to be black and white, right? So let's add some color to it. So for adding color, we'll use the bilateral filter. So that helps a lot in adding a color to your image. So we'll say color, and this color will be again cv2 dot bilateral filter. Okay, so we got a bilateral filter, and this would work on what? This would work on our image. While we want this to work on image, to get the color of our image. Okay, like the original colors that were there in your image. So it's important to get those colors. Otherwise, how we can get some new colors. So that's impossible. We need to then find out some other colors or ways to work on it. So we'll say colors, then we'll just give some values. So first one is D. So D we gave us 9. This is sigma color. So sigma color will be 250. And then again we need it would ask for sigma space. So sigma space will be 250. Now look what actually happens when we do this. Okay, so basically if we just print color, I don't think we will get much of it because we're just trying to make a bilateral filter. No problem, we'll again print this if we want. So this is the color. All right, now let's run this and try to figure out. Look, this came out. This was our first image. This was the second, like the grayscale image. This was the blurred version. This was the our image with the edges. And here we, on the fifth image, we got its color. We just derived the color. Okay. So whenever, like, next thing is just overlaying the stuff bitwise, so that we will do a bitwise and we will get our colors to it. Okay, so here I think you guys understand how this exact process we are following in this. So we found our colored version. Next thing we'll do is we'll just make a cartoon. The target is here. We are finally getting feel like the getting our exact cartoon that we just wanted. Okay, here is our cartoon. Now for that we will again use cv2, and in cv2 we will work on a cv2 dot bitwise and. So we'll do an bitwise and in the bitwise one, first thing we will need color is basically the color we got from here. We got our color, and with that color I think we need a second source. So color, and we need edges, color and edges we want to do a bitwise, and with that and try to print this. Let's run this and figure out what happens. It says bitwise and. Okay, so whenever you doing an and, we need. Okay. I understand what happened in this, because we're doing an and if we are doing an and operation, like a bitwise and operation, then remember, if both the inputs are true, then only an output can be true. So if we just convert it with the color and ages, like that's a kind of two different images. There's hardly any chance that this image will be like both the images at some point can give you a output as one, right? So let's do this and with color and color. So when you're doing this and with color and color, so it will give you one as output, and with that we'll mask as our mask as edges the work, the edges we just cut out from that, we'll just mask it on it, and ultimately it's time to see our cartoon. So here is the stuff we want. Now we look here we are we are using the edges, we are using the color, and we so here is the edges, color, and the image, right? So why not, let's comment this out, like the gray one and gray. So gray one and gray are these two images that we got as the first steps. So let's comment this out so that we can get some space to see how these images are coming out. All right, now let's run this. Here it is. Here is the look. Here is the original image we had, the image we took as an example, and here is the cartoon we have, like the cartoonized image. Look, this is not the perfect one, but look, this is somewhat cartoonized. This is a bit cartoonized. I mean, you can understand the difference, like the image we have, original image, and the cartoonized image we are getting out of it. But okay, this was the aged image and this was a color. So color is basically the look here, what was color? Color was the bilateral filter that we used on image to get a feel of the colored version of like the bilateral filtered color version. Okay, so again, have a look what we have here, right? So this is how we can work on Python to make a cartoonized version of images. So I hope I can make you understand how we can work on OpenCV and make something interesting, right? So comment down your thoughts. What else video you just want out of me? Like want as a next video? What else you are working on? I'd love to know about you. And thank you guys for watching this video. I hope to see you soon in my next video as well. Thank you, everyone.